Okay guys, welcome to the third installment of AP Human Geography Review. This is going to cover Unit 2, or at least the first half of Unit 2. It should take between 15 and 20 minutes. I'm going to try to be really efficient. You'll notice I skip over some slides. That's because you guys have these slides, right? You can go back and look at those smaller details that are important, but maybe not as important as the big ideas, okay? So again, we're just kind of focusing on the big topics here, making sure that you're not rusty, that you've got all the sort of core ideas that you need, and you can then build the rest of those smaller ideas up around that, okay? With that said, let's dive in. First up, you need to be able to think about how much population has grown recently, right? Unit 2 is all about population, ways to measure it, how it's changed, what impact that's had on the world, and how people move. Right? So why populations move from one part of the world to the other, or why they move within their countries or their regions, okay? So first up, some facts and figures. We hit 1 billion people for the first time somewhere around 1804, and today, of course, we're over 8 billion. People. That's a rapid increase, and as you can see, the speed at which we have increased is, well, increased. It is that's just the way that populations work, right? They grow exponentially. This is important to understand why populations have grown so rapidly. Once you get to 1 billion, it's much easier to get to 4 billion, and then when you get to 4 billion, it's much easier to get to 8 billion. This is probably something that you should know. You should also be confident in looking at graphs and charts that show this growth. You should be able to say, look at something like this and see rapid growth, acceleration in growth. But then notice that it is going to slow. The projections that demographers have is that over the next 50 years or so, you're going to see a decline in the growth rate. Now be careful, that doesn't mean that the population globally is shrinking. Right, you'll look there at somewhere around 1990 or so, 1980. You'll see the population growth rate peaked, and then it starts coming down. That doesn't indicate that the global population is shrinking. It just means that the growth rate is slowing. Okay? If this trend continues, and it probably will, you will, according to demographers, see a peak at somewhere between 11 and 12 billion people on Earth around 2100. Of course, some countries have already stopped growing and are actually growing negatively, right? So they're shrinking. Some have leveled off and are pretty flat, and some are still growing. This is, of course, something you're going to need to be able to think about and analyze in Unit 2. Again, just some interesting facts. Things that I might have in my mind is that there are a couple of countries that are much larger than everyone else, India and China. The U.S., of course, is a large country too, but it comes in at number 3. I might want to know that a large percentage of the world's population lives in less developed countries, less developed regions. I might also know that demographers study populations. That might help you understand some questions that you're asked. Okay, our first sort of simple, straightforward vocab sort of topic is population distribution and population density. These are two different things. You need to be able to think about how humans are spread out across space and how they live in these spaces at different density levels. For example, let's look at Canada. Canada has massive density. As you see there, that little lower part there around Toronto, the people are packed in, right? You can see that people in this region here, right along the border with the United States, is also pretty dense. You can see this region here from Vancouver over to Ottawa is less dense, but still pretty dense when compared to this massive region here, okay? This region is not dense at all. People are spread out all across this region, so the distribution here is pretty wide. The distribution here is not, right? Imagine zooming in, though. Let's say you zoomed in. Let's say you change your scale of analysis. Rather than looking at the map here, which is pretty wide, you zoomed in. What you would see is that people were distributed in all sorts of different ways. There would be some that would be linear. Right? They would be living along streets. Some would be fairly random. Some would be clustered around smaller areas, little regional areas within towns. And here it would be pretty random. There would be areas where almost no one lived, and there would be little areas that were actually pretty densely packed. Okay? Again, that's the difference between distribution and density. You should be able to think about that. You should also be able to think about why people live in the spaces that they do. Initially, it was for survival, right? People chose to live in places because, well, they needed water. They needed access to shelter. They needed access to resources like wood. Today, people live in the similar places, right? Because they settled there early on. Distribution hasn't really changed much. Density has, with some exceptions. Does it matter as much today, though, as it did in the past? Well, no, of course not. A city like Atlanta doesn't have as much access to natural resources as some of the early cities did. We don't need those resources now, or at least we still need those resources. We can just get to them more easily than we used to be able to in the past because of improvements in transportation infrastructure, improvements in technology. You're going to need to be able to analyze density with some depth. Okay? Distribution is pretty easy. Density might be a little tougher. You need to be able to think about these three different ways to measure density. First, arithmetic population density. It's easy. How many people are there in a given area? That's it. Put the two together, do the math, and you've got a useful measurement there. When you measure arithmetic population density, it's helpful. One thing you won't be able to sort of notice from that number, though, is how they are distributed within that area. Okay, that number is not going to give you any sort of insight into distribution. It could be random, it could be uniform, it could be clumped or clustered. There's really no way to know with that measurement. With this measurement, physiological population density, you get a slightly better picture. That's because it's taking the number of people and dividing it into the amount of arable land that can actually be used to produce food. In other words, land that is useful for sustaining human populations. This is probably a better, sort of more useful measurement. Okay, it's going to show up a lot, and you need to know that it is different than arithmetic density. You need to know why it's different. It's different because it tells us carrying capacity. It tells us how many people a given piece of land or a given country, a given region, a given continent can most likely support. Again, this is carrying capacity. How many people can a piece of land support? When you look at physiological density, think about Egypt. Egypt's a great example. It's a large country. It's almost 100 million people live there. If you just look at arithmetic density, it's going to appear that people have plenty of room in Egypt. The fact remains that most of Egypt is desert, is not sustainable for large-scale, dense populations. So all those 100 million people, or at least a lot of those 100 million people, have to live very close to the Nile River or the Nile River Delta. When you look at Egypt's physiological density, you can tell that actually Egypt is really crowded, right? There isn't a lot of arable land, and so the people that live there are crowded into that space. And that's why this is arguably a better measurement. A totally different measurement is agricultural population density. This is looking not at the total number of people, but the number of farmers compared to the amount of arable land. This is going to tell you how efficient farmers are in a given region. A lower number is better. For example, Bangladesh, there's a lot of farmers. The Netherlands, not a lot of farmers. They're similar-sized countries. So the Netherlands has a really low agricultural population density, about 31 farmers per square mile. Bangladesh has a very high agricultural density. Imagine the difference, what this looks like on the ground. Bangladeshi farmers are working very hard, often with their hands and simple tools. They have machinery too, but it's simple. In the Netherlands, most farming is happening at really, really high-tech, super efficient environments. They have GPS-controlled tractors. It does not take many people to farm the land in the Netherlands. This is the difference between a more developed country like the Netherlands and a less developed country like Bangladesh. Okay. Again, you also need to be able to think about population composition, right? It's great to be able to measure populations, know how many people live in a given area, what the density levels are. It's also important to be able to think about what's the makeup of that population. Demographically, is there a lot of language diversity or not? Is there a lot of religious diversity or not? Ethnic, racial diversity, age, sex diversity. Be able to think about what sorts of areas might have really diverse population compositions and what areas might not. For example, why is Lafayette an older city than Kennesaw or Marietta? Why does the South, skew Baptist versus cities like Baltimore skew more Catholic? Be able to think about how the United States demographically might be different than other countries in, say, Southeast Asia. Okay. Be able to reflect on that very, very generally. Be able to look at maps and other types of stimulus and sort of see ethnic composition. Be able to think about reasons that you might be seeing what you're seeing, right? Next topic, big one, population pyramids. They show so much, right? In theory, really all they're showing you is how many people, male and female, are alive at each given age cluster in 4-year chunks. That's it, right? But what you can do with a pyramid is pretty broad. You can see evidence of famine. You can see evidence of civil war. You can see evidence of unequal outcomes between women and men, meaning they behave differently and they have different health outcomes because of that. You can see gender imbalances, which typically need to be explained. Right? You should expect pretty much 50-50 distribution, skewing slightly female actually. But if you don't see that, well, something must be going on, right? There's something happening to the male population if there are fewer males than females at a given age, or vice versa. Be able to look at a pyramid and just kind of think broadly about what it's showing you. Here's a great example. Here's the U.S. pyramid versus the German pyramid. Germany on the left, U.S. on the right. You can see evidence of World War II on the German pyramid in 1950. Look at the group of 30 to 34-year-olds right there in the middle. Why are there so few of them? Why does it sort of pinch you in like that? Well, that's because those guys were in their early 20s during World War II. They were the people doing most of the fighting and most of the dying. You can see that here, right? You can also see evidence of a baby boom. Right? So as World War II was beginning, right before it was beginning, there was optimism in Germany. And people started having a lot of kids because of that economic optimism. Right? Those kids didn't fight in World War II, right? So they didn't die. There they are. You can see them. In the U.S., you can tell that there was a little bit of unexpected death from World War II, but it doesn't really show up. You also don't see a lot of women dying, comparable at least to Germany. It's because the war was fought in Germany. So women, civilians died. They didn't die in the U.S. because the war wasn't fought here. Population pyramids can show us a lot. They can show us baby booms and echoes of baby booms. Remember, population pyramids are essentially going back in time, right? As you move up, you're moving further and further into the past, and as you move down, you're moving closer and closer to the current day. We can see here, this is 2015, right? We can see this generation. We call them the baby boomers. These are people that were born to often families of veterans or families that were enjoying great economic times. So they had more kids than would normally be expected. When those people got to be of childbearing age, we can tell they had about 2 kids per family on average. Right? Much fewer than their parents had. Right? We can tell this because the population chunks are the same. One male parent, one female parent, you put them together, they get about 2 kids on average, the same size on the chart here, on the pyramid here. What's happening to the American population? Is it shrinking? Well, according to data from this pyramid, yeah, it is. Each subsequent year is a little bit smaller than the year before it. This shows us evidence of a shrinking population. Now, technically the U.S. isn't shrinking. We have really high immigration numbers, and there's some demographic momentum here keeping the population afloat. But there's reason to believe it might shrink in the future if immigration levels don't stay high. What's going to happen in Italy? Well, it's a very old population right now. It's getting older and older and older. It's going to be a problem for Italy. Think about what their government's going to have to do. They're going to have to spend money to take care of these old folks. How are they going to do that? Old people can't work anymore. You can't tax their labor. You're going to have to tax the young. What will the young do? Will they leave Italy? Will they seek jobs elsewhere? Maybe. They might. The government might decide we can't pay for this, right? And not sort of supply the services that old folks typically expect in Italy. They might not be able to. Whatever they decide to do, it's going to be very, very challenging for Italy to manage this. It's also challenging for countries that have a lot of kids, right? Those population pyramids like the one you see from Nigeria, which I think we'll look at in a few slides. It's very, very broad at the base. This means they have a ton of kids. They have to educate those kids. They have to provide them with health services. They don't pay taxes. They don't work, right? So this is challenging. It's important that you can compare pyramids, right? That you can see a pyramid from, say, Kenya, the U.S., and Italy. and talk about and think about how they're different. Right? Kenya has a lot of kids. You see that at the bottom there? The United States is a fairly balanced population, sort of middle-aged, and Italy is a much older population that is shrinking fairly rapidly. Don't let them fool you, right? Sometimes if you zoom in, if you change your scale of analysis, you go from the U.S., the countrywide scale, to the statewide scale down to the city or urban scale, it can get kind of confusing. Well, what's going on here in Illusions East Borough is it's a fishing village. Mostly men are doing the work. They're mostly young. And so that shows up on their population pyramid. Be able to change your scale of analysis of anything, population or otherwise. It's going to be helpful if you can do that. Okay. Be able to think about what impact guest workers might have. What's going on in Bahrain? Why are there so many men? Well, they're guest workers. They come into the country, they work, and they leave when they're 50 or 54. Most of them. Moving ahead, let's talk about another topic, the dependency ratio. I was kind of mentioning it earlier. The dependency ratio is the amount of young and old people you have in your population. To put it more precisely, the number of people below age 15, the number of people above age 64, combined with the potential, the number of people between 15 and 64 compared to the number of people under 15 and over 64. This is going to give you your dependency ratio. It's going to tell you how dependent the dependent population is on the workforce. The workforce is going to be paying into something like Social Security, paying into Medicare, Medicaid for us. Different countries have different programs, but most countries have some sort of program to care for the dependent population, and that takes tax dollars. It's going to be really difficult when your dependent population, in other words, your older, your young population, is larger than your potential workforce. It can be problematic. Countries attempt to address that in lots of different ways. Okay? They address it first by measuring it. They try to figure out where they're at. They use crude birth rate, the number of live births per 1,000 people, or they use total fertility rate, or TFR. That's the average number of children born to a woman of childbearing age. TFR is a better measurement. It communicates much more clearly what we're looking for. Okay. Countries with high TFRs or countries with low TFRs sometimes try to adjust their birth rates. Okay, they do things to try to make it so that families grow larger or families grow smaller. There's a word for that. Antinatalist policies are designed to make it so that people are less likely to have kids. Think about China and their one-child policy. Okay. What are other antinatalist policies that a country could enact? Could they charge people to have kids? Sure. Could they end subsidies that previously existed? In other words, could they stop giving people a tax break that used to get a tax break for having kids? Sure. On the flip side, there are pro-natalist policies. Countries like Japan, Italy, South Korea, the U.S. to some degree have pro-natalist policies in place. Now, remember some of the creative stuff we looked at with Japan. They offer free daycare services in some cities, and if your child gets sick while at daycare, they have a service that will take them to a doctor, then take them to a pharmacist to pick up the medicine that's prescribed, and then take them to a daycare for sick children. You can come pick them up when you get off work. No disruption to your work day. This is intended to be a pro-natalist policy to encourage Japanese families to grow larger. In the U.S., one of the pro-natalist policies we have is tax breaks. For every kid you have, you get a larger and larger tax break. All right, we're at 19 minutes. I'm going to go ahead and do the demographic transition model. That was quick. The demographic transition model is important. It's got 5 stages. You need to be able to think about what each stage indicates. Each stage indicates something different in terms of birth rate and death rate. And the result is going to be either population growth, decline, or it's going to stay flat. In stage 1 of the DTM, the demographic transition model, countries are pretty flat. Really, in reality, there's no country that's stage 1. These are isolated groups of people. They have high birth rates, high death rates, so the population doesn't really change much. At some point, medicine or technology is introduced, and people stop dying at the same rate. They live longer, and babies survive childbirth more frequently, and mothers survive childbirth more frequently. This causes a fairly rapid decrease in death rate. Now, birth rates remain high, so in stage 2, populations grow, and they grow rapidly. In stage 3, it starts to slow. birth rates start to come down. Death rates are still decreasing, but more slowly, and birth rates begin to come down. This is a country that's succeeding. It is starting to develop, okay? And because of that, there's going to be more money in the economy. Women are going to begin to work. There's going to be a lot more technology, a lot more access to health care, things like that, and that's going to further push down growth. At this point, most of the growth that's happening is due to increased longevity, meaning people live longer lives. As you move into stage 4, you see birth rates are really starting to get low. Death rates have flatlined pretty much. We're living about as long as we can. Toward the end of stage 4, you start to see that birth rates and death rates begin to merge. They start to become even. This is how you know you've moved into stage 5. When natural decrease begins to occur. In other words, it's no longer natural increase. You're no longer seeing a country growing larger or a region growing larger. It's starting to shrink because birth rate has went below death rate. Every time somebody dies, there is not a person being born to replace them. Again, this can be challenging for countries that experience this. They often institute pronatalist policies to attempt to sort of stave off stage 5. Okay. Just a different way to visualize the DTM here. It's really no different than that model or than that depiction. It's looking at a different scale of analysis, right? The first one, you're just looking generically at the DTM. In this visual, you're looking specifically at countries. Be able to think about what this means. How does this help you sort of think about what's going on in a country? When birth rates are declining, could that be a sign of good times? Could it be a sign of bad times? Birth rates are increasing. Could that be good times? Could it be bad times? I mean, it could go either way. It depends on what the death rates are doing. It depends on some historical context as well, right? Be able to think about that very broadly and very flexibly, okay? If you need a little more, go to your notes, right? You have printed notes. They're all in CTLS, and you can see a description of what each stage might look like. You can also see population pyramids to compare. Stage 2 pyramids often have broad bases. They should all have broad bases. Stage 3 pyramids have wide bases, but they're starting to even out. You're starting to see some flat sides on the pyramid. Stage 4, it's almost all flat. The flat sides have went up substantially higher, right? So here in Scotland, you see the basically flat side goes up to age 60. In France, it goes up to about age 70. Whereas in stage 3, you see Turkey, the flat sides go up to about 40, right? So that's the difference. In other words, this stage 4 populations are a bit older. Stage 5, of course, inverts. The pyramid starts to look like it's being turned upside down. Each successive generation is getting smaller and smaller, and this is making a pyramid that looks, again, inverted. Okay. Our last topic for this review session, sorry we went a bit long here, is this map. You should be familiar with a map or a data table showing you birth rates. You should expect to see high birth rates in sub-Saharan Africa. You should expect to see low birth rates in the most developed parts of the world, right? So Western Europe, you should expect to see lower birth rates. The United States, you should expect to see lower birth rates. Countries that are sort of in the middle, that are improving, countries like India maybe, there's still some poverty, but there's money being made. There are changes being made to their society. You should expect to see middling birth rates, okay? Be able to think about the role that religion might play. Why would a country in a more traditional part of the world, a place where maybe a more fundamentalist interpretation of a religion is still prominent, why might they expect to have higher birth rates? Well, there's probably two reasons, right? The economy there is probably not great. They're probably not interested in globalization. And the sort of gender roles there are probably more traditional. Right? Women may not have the same place in society that they do in more developed countries that we might find in Western Europe or North America. Right? This is going to mean that they're going to play a more traditional role. In other words, they're going to have a domestic role. They're going to have a lot of kids, and they're going to take care of those kids. We'll start on the next unit. Thomas Malthus. He'll be our topic in the next unit. We'll also get into migration, talk about Ravenstein's laws, lots of other important stuff. Guys, keep working hard. Keep asking yourself big questions as you go through the notes. At the end of the day, If you know what words mean, if the words you see evoke thoughts and they call to mind concepts, and you're able to produce examples just on the fly, you're going to be in really good shape, okay? Even if there's a few gaps, even if you're a bit rusty on a few topics, that's okay. Remember, typically around a 50% is going to earn you a 3. 3s get degrees. Okay, keep up the hard work, and we'll see you next time.